we go, peeps, coming at you from the computer to illustrate to you how to graph the solutions to systems of linear inequalities. So if you haven't already solved systems of linear equations, I suggest that you rock that earlier in chapter 7 before taking this on. Systems of linear inequalities are very simply, well, more than one inequality that needs to be graphed. So we're looking at systems of linear inequalities, meaning we've got things that look like they're lines but have those inequality symbols there. So let's go ahead and rock and roll. The basic idea is you're going to graph each inequality on their own, shading them on their own, and then what we want to look for is the area or the region in the graph where this first inequality here overlaps the solutions of the second inequality there. Where they overlap in their shading is where your solutions are going to happen, because that would be where both inequalities are true. So let's check it out. Y is less than 2x plus 4. Okay, well, we're going to graph this one like normal. So I'm going to graph it like it's the line y equals 2x plus 4. But I'm going to notice that we've got a less than symbol, so it's going to be dotted. So 2x plus 4, we've got a y-intercept here at 4, and then a slope of 2 basically over 1. So we're going to rise 2, 1, 2 over 1. Bam! Rise 2, 1, 2 over 1. Another one there. Rise 2 over 1 right there. Then we're going to lower 2 and go left 1, and lower 2 and go left 1, and lower 2 and go left 1, and so on and so forth. And all I need to do now, and this is actually the hard part on the computer, is I'm going to make the dotted lines go all through the points here. Oh yeah. There we go. There's our boundary. And now, oh boy, I gotta redo that last arrow. Hopefully this will come across a little bit better. That's better. Okay, so now we got a shade. Well, we're told that y is less than 2x plus 4, which is saying all the y values below this line. So I'm going to shade in the color that I used for this line, so it's going to be all here. And I'm just going to draw like straight lines like that. There we go. Now, you can also use a test point, and you could test 0, 0, and see how that works. So if I plug in 0 in for y, and I'll smush it in right here, we want to know is 0, that's the 0 value in for y, less than 2 times 0 plus 4. Well, that would mean that 0 is less than, that's 0 plus 4. Is 0 less than 4? Why, yes it is. So 0, 0 should be in the shaded region. Okay, so now I'm going to use a different color here. And I'll use a different color to do this line right here. Now, I typically, as I've shown you in earlier linear inequality videos, like to convert linear inequalities into slope-intercept form. So I'm going to add 3x to both sides before I even graph this. Just kind of get it in a form that I'm comfortable with. That leaves me with negative 2y is greater than or equal to 3x plus 6. And now from here, I'm going to divide everything by negative 2. Uh-oh. I'm divided by negative. There should be an alarm going off in your head. It's an inequality. So we have to switch the inequality signs. It's going to be y is less than or equal to negative 3 halves x. 6 divided by negative 2 is negative 3. So let me just circle this so we can focus on it. I'm putting circle in air quotes because, well, it's not really a circle. So now we're going to basically graph y equals negative 3 halves x minus 3. So minus 3 is down here. And then we have negative 3 halves. So that's going to be down 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2. And we'll do the same thing but go backwards. Up 1, 2, 3 over 1, 2. Oh, look, the intercept there. Up 1, 2, 3 over 1, 2. And I think that's good enough. Now it's or equal to, so this is going to be a solid line. Let's see if I can hit all of these points right here. Kind of shade it in. Ooh. There we go. All right, so we've got that line going on right there like that. Now, how do we shade though? It's less than or equal to, so we're going to go below this line. You could also do a test point of 0, 0, right? And we could see if 0, 0 works. If I plug in 0, 0, I get 0. It's less than or equal to. Negative 3 halves times 0 is 0 minus 3. Is 0 less than or equal to negative 3? No! So 0, 0 is not where we shade. So we shade on the other side here. Now, notice how I'm shading is kind of like in the opposite direction of the other lines. The reason why I do that is so that we can point out the area where both shaded regions overlap. And if you take a look at this, it overlaps right in here. And it's not just in here that the solutions are, it keeps extending down, right? All throughout here. So as this line goes like that, this line goes like that, all of those points work in both inequalities. So let's pick a random point so I can show you why both work. All right, so we'll do the point -2, -5. If I plug -2, -5 into the original inequalities, that's -2, -5, they should make both inequalities true. So I'll plug -5 in for y. I'm plugging into this right here, which is less than 2 times -2 plus 4. And that leaves us with -5 is less than -4 plus 4, which is a true statement, right? That's saying that -5 is less than 0. So that's true. So now we need to make sure that it's also true for the second inequality, and then we know that we've got the right region. So I take -2, plug it in there. I get -3 times -2 minus 2 times -5, and we want to know, is it greater than or equal to 6? Well, -3 times -2 is 6. -2 times -5 is 10. Is 6 plus 10 greater than or equal to 6? Yes! So we have a point in the region that we see as our solutions that works in both inequalities. Bottom line, peeps, graph each inequality like you know how, like you did in single linear inequalities. And then wherever their shading overlaps, that is the set of all the points that works in both of these inequalities, known as the solution set. I'm going to do another video where I do one more of these problems just to make sure you got it down well. You know what? I'm not going to do another video. I'll do it on the flip side of this video. So this will be a longer video, and you can check it out and rock and roll from there. So I'll see you on the flip side. And here we are on the flip side of the video, as promised. I'm going to go over a second problem here. We're going to graph out each linear inequality on their own and look and see where their solution sets overlap. Let's check it out. So I'll start out with this first one here. Y is less than -2x plus 3. So I'm going to graph it. Y-intercept at 3, slope of -2 over 1. So we're going to go down 2 over 1, and down 2 over 1, and then down 2 over 1. And then we'll go up 2 over 1 just to kind of get a couple more points in there. And it is less than strictly, so that's going to be just a dotted line that kind of goes through all those points. And again, this is a rough drawing, right? It's not a perfect drawing. So we've got our dotted line, and it's less than, which means I'm going to shade below, right? It's all the y values less than, so I'll shade below. You can also, as a reminder, do a test point. If you plug in 0, 0 into this, you will get 0 is less than -2 times 0 is 0 plus 3. And that's true. 0 is less than 3. So 0, 0 should be in the solution set. All right, then we're going to plot y is greater than 1, and I will do that in a completely different color. So let me pick a different color here. Let's go with orange. Okay, so y is greater than 1. Well, we're basically plotting y equals 1. And so that's going to be a dotted line because it's greater than. So we're going to go all across y equals 1, which is normally a horizontal line, right? Sweet. And now we're going to shade in all the y values more than 1, which is all the y values above. Like that. Do you see where it overlaps? I do. All in here. So our solution set, all the points that work are all in here. Pick a random point in that solution set. So let's do -5, 3. If -5, 3 works in both inequalities, then looks like we've shaded the right area. So the overlap again is our solution. So I'm going to plug in 3 for y in this first inequality is less than -2 times -5 plus 3. And that's a true statement because 3 is less than -2 times -5 is 10 plus 3. Sweet. And then for y is greater than 1, we can only plug in 3. So you'd get 3 is greater than 1, which is also true. So guess what? We've got the right area shaded. Sweet. And that's it, peeps. A little bonus coverage on a second system of linear inequalities. Again, shade each system. Well, basically shade each linear inequality normally, like you would solve it, and look for the overlap.